so with 10.4, we're going to talk about the algebra of matrices today. And two matrices are equal if they have the same entries in the same position. Okay, so they have to have the same entries in the same position. So this just talks about they're equal if they have the same dimension and then corresponding entries are the same. Okay, so it really does have to be the exact same. So an example would be, okay, if you have 1, 2, 3, 4, that would be equal to 1, 2, 3, 4. Okay, so it has to be the same entry in the same position. So what you might have to do is you might have to solve, and if you're going to solve, like in example 1, you have to find A, B, C, and D. Okay, so if you're going to find A, B, C, and D, if you know A, B, C, D is equal to 1, 3, 5, 2. Okay, so since the two matrices are given as equal, we know that whatever is in position A has to be equal to 1, which we already have written down. But your A value has to be 1. Your B value would have to be what? 3. Your C value would have to be 5, and your D value would have to be 2, okay, because your matrices are equal. Okay, so they're just your corresponding entries. All right, and then the next thing we're going to talk about, so those are equal matrices. The next thing we're going to talk about are addition, subtraction, and the scalar multiplication. If it's scalar multiplication, what does that mean? Yeah, you're multiplying by a constant. Good. So you can add or subtract two matrices if they have the same dimension. Okay, so two matrices can be added or subtracted if they have the same dimension. If they don't have the same dimension, then their sum or difference would be undefined. So if they don't have the same dimensions, then your answer would be undefined. The way that you add and subtract is you just add or subtract the corresponding entries. So if it's in the same position in one matrix as it is in the second, you're going to add those together. When you multiply a matrix, you're going to multiply every element of the matrix by that number. That's called the scalar product. The way that you guys will see this is you'll think of it as distribution. So you would multiply every single entry in your matrix by that scalar multiple, okay, by that constant term. And then I'll show you some examples of that. Okay, so the next slide is just going over one of your popular blue boxes in your book, the sum, the difference, and the scalar product of matrices. So if you were finding the sum, you would add those two together in the same position. If it was subtraction, you would subtract the two. And if it was scalar multiplication, then you would multiply the two. Don't worry too much about this terminology. This is something that's going to come very naturally to you. So if you're given the following matrices, so you have A, B, C, and D. For part A, what we're going to do is we're going to add A and B together. Okay, so if you add A and B together, first, you guys see how A is a 3 by 2 matrix and B is a 3 by 2 matrix? Okay, so because they're both 3 by 2s, you can add them together. You're just going to add, what's 2 plus 1? 3. Negative 3 plus 0. Negative 3. Okay, and then if you look on your next slide, I actually already have that for you. So 2 plus 1 is 3. Negative 3 plus 0 is negative 3. 0 plus negative 3 is negative 3. 5 plus 1, 7 plus 2. And then negative 1 half plus 2 would be 3 halves. Okay, and then if you were doing subtraction, it's very similar. This is a 2 by 3 and this is a 2 by 3. So to subtract, you're just going to do 7 minus 6, which is 1. Negative 3 minus 0, which is negative 3. 0 minus a negative 6, which is going to be positive 6. And then so on and so forth. Do you guys have questions about the addition or subtraction? Okay, and then the next one, it's asking us to add C and A. Well, matrix C is a 2 by 3, and matrix A is a 3 by 2. So this is going to be undefined because we can't add matrices if they have different dimensions. Okay, and these do not have the same number of rows and columns. All right, you guys ready for the next one? Okay, so the last one is going to be a scalar multiple. So it says 5 times matrix A. So if you're doing 5 times matrix A, all you want to do is multiply each element by 5. So 5 times 2 is going to be 10. 5 times negative 3, negative 15. 5 times 0, 0. 5 times 5, 25. Okay, and then so on and so forth. Okay, do you guys have any questions for me on those? Good? All right. The next chart is going to go over a few properties that hold for addition and scalar multiplication. And not all of your properties are going to hold. So these are the ones that do. The first one is the commutative property. And that tells us it doesn't matter if we add A plus B or B plus A. Okay, you're still going to get the same final result. The second property, the associative property of addition, that's going to hold as well. So if you decide you want to add A and B together first and then C, you would get the same result if you added B and C together first and then added that to A. Okay, and then the next one is the associative property of scalar multiplication. So for that one, they're just saying it wouldn't matter if you multiplied D times A first. Okay, or if you did C and D first and then multiplied it by A. So the order that you're multiplying those in does not matter. Okay, and then the last one is your distributive property. So if you have C plus D times A, that's the same thing as multiplying C by A and D by A. And then for the next one, it says C times A plus B. And that would be the same thing as multiplying C by A and C by B. Okay, so all of those you would get the same answer for. Okay, so our next example, it says solve the matrix equation 3x minus 4a equals b, where, and it's where A is equal to the matrix 4, negative 1, 3, 2, and B is equal to negative 13, 1, negative 3, negative 2. So when it says to solve the matrix equation, what our goal is we want to solve for x. And there's actually a few ways that you can do this. So the first strategy would be to go ahead and substitute in our matrix for A, our matrix for B, and then you could solve. Or you could actually solve that equation first and then do your substitution. So that's what I'm going to do. So if I have 3x minus 4a equals b, bless you. Notice that all your matrices are capital letters here, because x is going to be a matrix. Okay, so if I wanted to get x by itself, what would I do first? Yeah, add over your 4a. So then I'd have 3 times x equals b plus 4a. Okay, and then Alex, what would I do next? Yes, you do. If it's 3 times x, how do you move it over? If you have 3 times x, what can you multiply by to get rid of the 3? Three times what is going to be 1? 1/3, okay? So you're going to multiply both sides by 1/3. And can you guys think about why I want to multiply by 1/3 instead of just saying divide by 3? That, yeah, because you're going to use it as a scalar multiple and then you're going to distribute. So 1/3 times 3 is 1, so this will be x. And this is going to be 1/3. times b plus 4a. Now at this step you have a choice. You can stop here, or if you wanted to distribute the 1/3 and do 1/3 times b plus 4/3 times a, you could do that. Okay, what I'm going to do is I'm going to go ahead and substitute in my matrices now. Okay, so what I have is x equals 1/3 b plus 4a. So I'm going to go ahead and substitute. Matrix B is -13, 1, -3, -2, plus 4 times A. Now I'm writing this out as 4 times A. When you're doing your homework, if you want to go ahead and distribute that right away, please feel free to do that. So because it's a scalar multiple, I have to make sure, I want that to be my parentheses. I have to make sure that I multiply the 4 by every element. Okay, so 4 times 4 is going to be, 16. Everybody? Okay, kind of weak there. 4 times -1, -4. 4 times 3, 4 times 2. Thank you for the 2 of you who are participating. Okay, and then what we're going to do now is we're going to add. Okay, so we're going to add these together. So the first thing I'm going to add is -3 plus 16, which is what? What? There we go. And then 1 plus -4? -3. -3 plus 12? 9. -2 plus 8? 6. Okay, good. And then your last step is just going to be to distribute the 1/3. And for this one, it's going to be pretty nice because they are all divisible by 3. So it's really just like we're dividing by 3. It's okay if you get a fraction. Okay, you are going to have fractions. So 3 divided by 3 is 1. 9 divided by 3? 3. -3 divided by 3? -1. 6 divided by 3? 2. Okay, so then this is our matrix for x. Yeah. And
should we multiply that into all the time?
yes. Yes. If it's division, yes, you should do that. All right. Okay, so I'm actually going to save the multiplication of matrices for tomorrow. And then let's go ahead and flip to our last slide. Okay, so for the rest of the time, I'm just going to give you time to work on your homework from yesterday that you didn't finish and part of today's. So what we covered today was number 7 through 23. So you're going to do 7 through 23 odds, and then we'll cover the rest of this section tomorrow.